from numpy package which are useful, and some of them are shape, reshape, transpose, and we'll see some basic math operations, and we'll see some of the methods where you can pass an array as parameter, the numpy array as parameter. So let's get started. Let's see what shape is. Shape method provides dimension of the array. So here not like one dimensional, two dimensional, so probably it provides dimension in terms of rows and columns. And then dot reshape method, it is useful to change an array, numpy array, from one dimension to other dimensions. All right, so let's get started. Let's see what shape is. For example, let's say a is equal to np dot array, and it is 1 2 3 4 5 6. Okay, and I would like to know what is the shape of this a dot shape. And let's see, the shape is like 6, right? Now if at all let's consider a 2D array here. All right, 2D array, that's what I'm trying to put here. And let's see what the shape is. It is 2 by 3. Why? Because if you print this numpy array, it is like this, right? 1 2 3 4 5 6. It is 2 rows and 3 columns. So shape, a dot shape, exactly tells that it is of 2 rows and 3 columns. So this is all about shape. It is as simple as it is. All right, now let's see what is a reshape and how can we use reshape. Now let's say you have a numpy array, which, let me create or generate one dot rand int 1 to 100. I want like 20 of them. Okay, and then let me print this x to show you. So I am creating a numpy array which has 20 values, and all the values are random, and from which are between or from 1 to 99. Okay, okay, then let me also comment the code and let me run so that it would be clean to see. Okay, this is your array x. Now this is a one-dimensional array, right? It's a one-dimensional array. Now if you see the number of elements, 20, right? Number of elements is 20. So what are the different combinations of 20? Let's say that it is 20, so I can say 10 times 2, 2 times 10, 5 times 4, 4 times 5, and also 1 times 20, or 20 times 1, right? So these are different combinations that are possible. All right, these are all the different combinations that are possible. So what we can do is, you can take a one-dimensional array like this with 20 elements and reshape the array to all these combinations. Let's see what I'm talking about. Okay, let's see for 10 by 2. So what I'll do is x dot reshape, and I'll say 2 comma 10, and I'll say this is some y is equal to x dot reshape 10 comma 2. So that's what we wanted, right? 10 comma 2. So let's also comment all these, and let me print y. Okay, and let me run this cell, and see, this is your one-dimensional array, and I reshaped this one-dimensional array into 10 rows and 2 column array called y. So your y is 10 rows and 2 column array, and the elements are the same, right? 95 99, 95 99, 18 86, 18 86, 30 86, 30 86, and so on. So using reshape, we can reshape it. So you can reshape if it is 2 by 10, just make it as 2 here and 10, and if you run the cell, you get a 2 row 10 column numpy array. And again, you can do it as 5 by 4, 4 by 5. You can try all these things, and you'll see that you can take a one-dimensional array and and reshape it based on the number of elements it has. Okay, so this is what it is. Now let's take a two-dimensional array. Let's take a two-dimensional array. Let's say we have got like p is equal to np.numpy, simple two-dimensional array. We'll take it. Okay, just a second. So it's going to be a nested list, and I have these elements. Okay, and if I print p, what will happen? Where did we go wrong? Okay, this is comma. Okay, and again, where did we go wrong? Numpy has no attribute numpy, so np dot array. Okay, so np dot array and then a nested list. It would give me a 2 by 3 numpy array, right? 2 by 3 numpy array. So that's what it is. If you put p dot shape, it says like it's a 2 by 3 numpy array, right? Okay, now 2 by 3 numpy array, right? If you multiply 2 and 3, it is 6 again. It is 6. So what I'm trying to say here, we have seen previously. So 6 could be written in the form of like 2 into 3 or 3 into 2, right? Or 6 into 1 times 6. All these combinations you can write them, right? Let me comment it, and let's do it. Like, let's use dot reshape method and try to get to 2 by 3. So what I'll do is I'll say let q is equal to, okay, np dot reshape, np dot, sorry, not np dot reshape, what is it, p dot reshape. Yeah, p dot reshape. I want to reshape this p, right? P dot reshape into 2 and 3. So probably it is already 2 and 3, right? So I would like to do it in 3 and 2, 3 rows and 2 columns, 3 rows and 2 columns. Print q simply. Okay, then see what happens. So this is what the array is, 2 by 3 array. Now what we have done is we have converted it into 3 by 2 array. So it has 3 rows and 2 columns, and all the elements are same, 1 2 3 4 5 6, all those elements are present, but we made it into transformed from a 2 by 3 to 3 by 4 based on this 6 is what number of rows times number of columns, right? That is what we have done. Now if you want to make it a 6 by 1, see, I'll do 6 and 1. If you pass it, you're transforming this one into 6 rows and 1 column. You can as well do 1 and 6, and what will happen? So it will be like this, 1 row and 6 columns. And this is not just limited to 2D, it is also you can also do a 3D as well. For example, let's say n is equal to np dot once, okay, let's say 5 comma 4. It has to be a tuple, 5 comma 4. Okay, then if I print n comma n dot shape comma n dot dim, okay, and I'm adding on the parameter to make it a 3-dimensional. Okay, let's see what happens. it's not dim, it's ndim. Okay, now what I have generated here is a three-dimensional array, and is a three-dimensional array with 5 sets of 4 rows and 2 columns. So this is set 1, set 2, set 3, set 4, set 5. 5 sets with 4 rows. 1, 2, 3, 4. 1, 2, 3, 4 rows. And 2 columns, right? 1, 2, 1, 2, 2 columns. And it is of dimension 3. Okay? Now you take this one, 4 and 2. So 4 and 2 is like what? 8, right? Combination of 8. Oh, just a second. Something happened here. Okay. Okay. Now what you'll do is, here it is 8, right? And currently it is 4 by 2. Maybe you do 8 by 1, 1 by 8, 2 by 4. All these are possible. Let's see a few of them. Let's say 8 by 1. What you'll do is, let's take m to be n dot reshape. You want to reshape n, right? And you are going to say 5 comma, okay, you're going to say 5 comma what, 8 comma 1. All right, and let's say print this m. Let's see what happens. So you're basically transforming the entire thing into like, and you are saying that give me 5 sets of one matrix, one numpy array which is of 8 rows and 1 column. So this is what it is, right? You get 1, 2, 3, 4, 5 sets. 5 sets with 8 rows and 1 column. So you have transformed, a 3D array also. And let's say if you don't give here like 5, if you remove the 5, you'll get an error. Okay, so you can reshape a 3D into another 3D, but you cannot reshape a 3D to a 2D. So this is all about shape and reshape. Now let's move on to something called as transpose. Transpose is just transposing of a matrix, if you have seen. So something similar to that. Let's say if x is equal to np dot array, and we have got a nested list of, like, let's say 1, 2, 3, which we have seen similar numpy array previously. And if I print x, what you'll get a 2 by 3, right? 2 by 3. So let's say print x and x dot shape. Okay, and then what I'll do is I'll take y is equal to x dot t. Dot t is the transpose, and let me print y and y dot shape. So what am I doing? I'm transposing a 2 by 3 to a 3 by 2. It is as simple as it is. So this is all about transpose. Now let's see some basic operations. Let's generate a 20 element one dimensional numpy array using random.randint. Okay, and then I'm going to reshape it, since it has 20 elements, into a 5 by 4 array. Okay, numpy array. And then what I'll do is I'll firstly print that 5 by 4 numpy array, and then multiply. I want to multiply each element of that numpy array with 2. Okay, and this is how we are going to do. You are simply going to say x underscore new into 2, and I want to add each element of it with 2. So I'm going to simply say this. So I'm going to simply add an integer to a numpy array, which is not possible with Python less. Again, I can, if you want to divide each an element by 2, I'm going to use this operation. If I want to power of 5, each element to the power of 5, I want to do that transformation, I'm going to use this simple. And I want to, in this case, I want to square each element with itself. in this I want to cube each element. Okay, let's see what happens here. So what we are doing is we are generating a 5 by 4 x underscore new is a 5 by 4 numpy array with 5 rows and 4 columns, right? This is what it is. Now we have seen that if you multiply by 2, each element is multiplied by 2. If you simply see 52 into 2 is 104, 48 into 2 is 96, and so on. Okay, you can add, you have added 2 with each of the elements, you have divided 2, so this is what you get when you divide by 2. And 52 power 5 is this much, you know, you are doing power of 5 and you are saying square, right? You are multiplying by itself. So 52 square is 2704, 48 square is obviously 2304, and so on, and you're cubing again here. So this kind of operations of adding an integer to a numpy array, or multiplying, dividing, you know, squaring with itself, is very much possible. And these are the basic operations. This is how you do in numpy using numpy package. Now let's move on to some of the methods wherein you pass numpy array as a parameter. Okay, so let's create a numpy array here, a one-dimensional numpy array here with 20 elements, and then let's reshape to 5 by 4. So you have a 5 by 4 numpy array. Okay, and then you just use something called as np.sqrt, and in the parameter just pass in this numpy array that we have written, array underscore. Okay, and again there is function or method called as np.max, which provides or gives the maximum element in that array. And also similar to that, there is np.minimum, which gives you what is the minimum element inside that array. And argmax gives you the index number of that maximum element, and argmin gives a minimum index of the minimum element of that. And there are certain functions or methods like np.log, np.sign, which are as simple as just doing log to each and every element of that numpy array, or applying sign to each and every element of the numpy array. And finally we have something called as np.round, which is similar to that we have seen in Python, the round function, where you can round the values to specified decimals. Now np.round and we have already seen np.around are both equivalent functions that do exactly the same thing. Either you can use np.round or np.around. So if you see the documentation here, np.round and is equivalent function to np.around, it returns around. Okay, anyways, so these are some of the functions. So let's run this cell, okay, and see what happens. So this is the array it has produced. It's a random array, and you have used np.sqrt, and it square roots, I mean it finds the square root of each and element, and this is how it is. And max, the max value, np.max provides the maximum value of an entire thing, which is 94, and it is 94. And the minimum value of this is 9, that is what it is. np.min provides that. np.argmax provides the index 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. This is the index, which is 15. Similarly, it provides the index of 9, which is 9. Okay, and it does the log, applies log. When you do np.log, applies log to each and every element, and it provides the answer. Similar to log, it does sign. And the round also, if you have specified the decimals to be 2, it rounds off these random values to 2, you know, 2 decimals, everything to 2 decimals. So what are we rounding off here? Let me see. We have created another array, okay, np.random and 4 by 5. So it is a 4 by 5 array, and that array is this. This is that array, okay, and then we are rounding this off to 2 decimals. That is what it is. So it is all about a few methods here which you pass argument which is a numpy array. Now let's move on to a property. This is not a method. D type is not a method. So if it is not a method, then it would not have this brackets, right? Round brackets. Okay, it just has this. It is dot D type. So let's say uh, if X is an array, np dot random dot rand int, and then you'll say 1 to 30 and 15, right? And then you'll say x dot D type. What will happen? So it will tell what type of elements are present in your array. So for example, let's just print x comma x dot D type and see what happens. So this is your numpy array, and it contains all elements which are integers. That's what it says. It is int 64. If I, let's say, if y is equal to np dot I 7, I want to see what kind of what does y dot D type give me. Okay, so it is a identity matrix, 7 by 7 identity matrix, but the y dot D type gives me float 64. Why? Because that by default the result displayed here, all the ones are in float, so it is not 1, it's 1 point if you observe here. So the D type is float. So D type is a useful property to find what kind of elements are present in your numpy array. Now there is something called as a copy dot copy f dot copy. It is as simple or same or similar to that of what we have in Python. Now let's say x is equal to np dot zeros, let's say 8, and I want to print x. Okay, let's not take zeros, let's take ones. Okay, and let's take 4 by 2. Okay, let me print 1, let me print this, run this cell, and we'll get a 4 by 2 ones matrix, right? Now I want to make a copy of this. I don't want to lose this function because I want to do some basic math to it, and I want to make a copy of this. So what I'll do is x1 is equal to x dot copy, and then I want to do x1 plus 2. I want to add each and element of this with 2, and then I want to print that x1, and I want to make sure that my x stays as it is not manipulated. So let's see, right? Wait a second, what happened? Okay, x1 is equal to x1 plus 2. So what I did is I have this x, and at the end also I have retained that x. So x is 111, x is 111. Now I have made x1 a copy of x, which is a copy of x, and I did some basic math operations. Okay, and if you see x1 is changed, it is transformed. Alright, so this is how you can use dot copy. So these are some of the properties that we have seen. I mean, not exactly the properties. We have seen one property which is D type, but we have seen some inbuilt methods, starting with shape, reshape, transpose. Then we have seen basic math operations and methods like sqrt, min, max, argmin, sign, round, which accepts a numpy array as a parameter, and then we have seen D type, a property, and then finally we have seen dot copy method.